Hello everyone, today we will take an overview about the effect of CT saturation and CT remanence effect in case of the distance protection. And we will use in our session, we will use the RelaySimTest software 5.00. And as you can see, here is the start page of the RelaySimTest. We have option to create a new test document from scratch or open an existing test document. Or also we have some sample documents for the feeder, for the line and for transformer sample documents with different and realistic fault behaviors, as you can see. So today we are going to test the line distance protection with the CT saturation effect. Okay, so I will open the file. As you can see here, we have an overview about the file. You can enter your data here about the company and any comment you need to be added into your report view. And here is the report, which you can select and tailor or customize your report content as you like. Also, you can put a logo here for your company. Then we have the power system data. As you can see here, we have different topology. We have a line, overhead line. Okay. As you can see, here is the line parameter. The line length is 32.5 kilometer, and we select the line parameter to be expressed in R1-, X1-, R0-, and X0-. And we have different methods to express and to simulate the line parameters, as you can see, in milliohm per kilometer. And also here is the orientation of the line from 0 to up to 100%. And we have a bus bar, we have a CT, VT, and the in-feed A and in-feed B. And we have a parallel line with a circuit breaker open, which means there is no effect right now in the parallel line. But for the CT, as you can see, here is the CT ratio, 600/1. And as you can see, we can open the CT data from here. So we can use a user-defined CT or a different standard CT customizable CT ratios, or you can import it from the CT analyzer directly from choose file, and you can browse in your file explorer to the XML file, as you can see, and you can select open. Then now I will explain what we have in the CT data. So we have here the user-defined CT data. The rated burden is 10 volt ampere. The accuracy limit factor is 10. We have also the winding resistance 1.5 ohm. The unsaturated inductance 5 Henry, and the saturated inductance is 3 millihenry. And the remanence flux density is 10%. We can simulate up to 100%. So we can select this remanence effect to be edited, as you can see. So we will make it 100% to simulate remanence effect with different values. Then you can click done. Here also we have the VT ratio, as you can see, and also you can simulate the linear VT, or you can simulate a CVT voltage transformer. Also, if you take this option, you will simulate the traveling wave pulses. In the CT also you have to enable simulate saturation to allow you to simulate any saturation effect on the protection system. Okay, then we can open a single line in feed test fault. As you can see, you can insert a test case from here. You can add test case, then you can adjust the fault, or you can select the fault to be line to ground, line to line, and also with a different parameters. As you can see here, we have the line fault inactive, and we select to be line 1 to neutral, and the fault location at 0% of the line. We also can simulate different fault location from the very parameters here. You can simulate different fault location. As you can see, we have 0, we have 74, we have 95. Also, you can simulate different CT remanence effect at 0%, 10%, 20%, and so on. Also, you can simulate any kind of parameters, like if you select the fault, you can simulate different inception angles, different fault resistance. Also, for the CT, you can simulate different remanence effect on the L2 and L3. Then, after simulating, you will have the option here to check the waveform of the current. For example, here the line 1 to neutral fault at 0% from the fault location, and 80% line CTA remanence effect or saturation effect. And as you can see here, the waveform have a DC component or a flat region, which indicates there is this CT is saturated with 80%, here also with a 90%. But if you need to compare with the sinusoidal waveform or the fundamental waveform of the current, you can select the 0%. Here is the pure sinusoidal waveform without any saturation effect. So you have different possibilities also to add the fault location at different fault location. For example, at 0%, at 74% from the line, or at the 90% or 95 or 100% from the line length. Then you can simulate and you can start to execute the file. But before starting to execute the file, I will give you just an overview about the hardware configuration. Now we are injecting the 3 voltage channel through the CMC 500 output A and 3 current channel up to 30 amp from the CMC 500 USH output B. And the binary input we are using, which is a trip contact, is a wet contact, and the nominal value of voltage is 24 voltage. Then you can go for the test case, and you can select test case, double click on the test case, and it will allow you to run the test for the selected point from here, or you can execute all the test shots. And let us see now what is the effect of the CT saturation on the protection system. Now the first point, line 1 to ground, and 0 remanence effect and 0 line fault location. Here is the zone 1 tripping time, which is from 0 up to 50 milliseconds, depends on the internal processing time of the relay. Here is at 80%, there is 90% remanence effect. As you can see, the trip time is delayed with some millisecond. It is about from 10 to 15 milliseconds, which is the internal processing time affected by the CT saturation. So in addition to see the difference in the waveform of the CT itself, also you can select and you can see the realistic behavior and the realistic trip time from the protection relay in different cases and in real life fault events. And this is something that cannot be simulated using the test universe, but you can simulate it easy by the easy to use software called the RelaySimTest. As you can see here, at 95% remanence effect, the trip time is 67.6 milliseconds. Okay, which means the protection relay have internal compensation for this CT saturation, but it will take some time as internal processing time to compensate the CT waveform and to give you the correct trip result. And for example, here is some trip points at 90 or 95 in the line length, but for different fault loops and with 0 remanence effect. And here is the zone 2 trip time, which is about 400 milliseconds. So here is the test result, and here is the waveform, if you can see. Also, if you need to check the measurement of the CT itself, you can pin the values to your dashboard here to be simulated. And you can see here the current measurement in primary and secondary and in symmetrical component as well, also as a phasor diagram. And you can configure this dashboard from here to show you any kind of measurement or waveforms. Also, if you select the waveform, for example, here you will see the different waveforms, as you can see, at different CT remanence effect. As well as also the CT waveform will be different, and the trip time of the protection relay will be different, but you can see the effect in case if you have a CT remanence effect up to 90%, and you can make zoom for the current waveform to see what's going on and what is the difference. As you can see, here is the waveform of the current at 90% of the CT remanence. For example, if you can compare with 0%, here is a complete and fundamental waveform without any saturation effect, and here is at 99%. You can see here the effect and also the effect in the trip time of the protection relay.